Hi, this is Slava Kurilak, and I am super excited for you to join us today as we discuss manufacturing and artificial intelligence technologies. I want to welcome you. I want to welcome our future viewers and listeners, our existing listeners. This is a live stream aiming to bridge the gap between manufacturing and AI technology. This live stream is meant to educate, inspire, and share best practices for how entrepreneurs, executives, and decision makers can leverage AI technologies to solve manufacturing problems. I encourage you to ask any questions during this live stream. I encourage you to make any comments that you wish. You can do that by leaving comments below, and you can also feel free to do that while I am on the live stream. I will overlay all chats in the side. You will see them show up, so feel free to make any comments or questions. I want to start this live stream by asking everyone who's joining us today where you're from. Please type your city, your country, your state, any piece of information that allows us to say hi to you and give back to the community. And after we do a brief round of introductions, I will get into the live stream. So again, if you're interested, feel free to leave your city, country in the comments below. So let's jump into the introduction. For those who are not familiar, my name is Slava. I am based from Vancouver, Canada. I'm wondering if anyone is joining us today from Canada as well. And awesome, we have Mo from Perth, Australia. Hi, Mo. It's great to have you with us today. As I said before, I am from Vancouver, Canada, and I run an AI agency based in Vancouver. AI, for those who are not familiar, is a technology that helps individuals and companies deal with data. And this is part of our discussion today. We're aiming to help companies to understand how they can leverage AI technologies to solve industry problems. So we also have Rael joining us from Vancouver as well. Hi, Rael. It's great to see you as well. So to kick off this live stream, I want to ask everyone here, what are some of your biggest frustrations or biggest challenges that you face in manufacturing, right? So on a high level, we have three major goals that most companies are interested in. We have the goal of increasing revenue, reducing cost, and saving time. Having said that, there are many sort of specific goals that individuals can have, and while they're in the industry, right? Everything from improving the manufacturing process to reducing number of defects in the manufacturing line. So if you have any specific problems or frustrations, feel free to leave them in the comments below, and I'm more than happy to offer my insights on how you can use AI technology to solve them. This live stream is meant to be interactive, so feel free to do that at any given time. Let's jump deeper into the topic of manufacturing. So for those who are not familiar, I previously wrote a blog post on this topic, and I want to share this blog post for anyone who's interested to dive deeper, for anyone who is unable to stick with us for the duration of the hour. I will now post it in the comment section below or to the side. Feel free to check it out and read more about the specific use cases of AI in manufacturing. And having said that, I do want to highlight a few common use cases that I see that are necessary for companies to solve today, as well as a few up-and-coming technologies which are very promising for anyone to tackle and solve the problems of tomorrow. So one of the most commonly asked sort of problems to solve in manufacturing is how can we better manage our machinery, right? And that is the use case of machinery maintenance or machine maintenance. So this is a use case where we're aiming to reduce how much we lose as the result of machinery being out of service, and we're aiming to maximize the machine efficiency, hopefully saving the company time and money, right? When you have a machinery and it's costing millions of dollars, You don't want that machine to go down for an hour, for a day or longer. You want to make sure that the machinery is operational as often as necessary. And the question is, how can AI technology help with this use case? So this is a common use case we hear from our clients and sort of industry experts. Being able to detect machinery faults, being able to detect when something is going wrong is one of the best ways to use AI technology. And this is the context of where we're aiming to predict machine failure, and we're aiming to use available technologies to do that, right? So what are some of the possible tools? So the first common use case of predictive maintenance using AI technology is something called predictive modeling. Predictive modeling are aiming to predict future scenarios that have not occurred yet, right? This is where we're looking at historical data, sensor data, machinery data, and we're trying to understand when will the machine fail next? What is the probability of that failure, right? This is a very common use case. Machine maintenance or machine failure prediction is the first example that I wanted to share with you. And I encourage everyone who's joining this live stream to, feel free to add your comments, add your thoughts, and I'm more than happy to surface them for everyone to at least pay attention to. So the first use case I've mentioned so far is predictive maintenance. So have you and your company dealt with maintenance issues before? What has the cost been, right? These are very important questions to answer, and coming up with a solution that's using predictive modeling is one of the ways to address that. And there's always other ways to do this as well, right? So I've mentioned so far predicting machine failure, but we can also predict internal failure of sort of the different measurements and tests that are being sort of happening on the manufacturing floor. We can predict equipment failure, reduce downtime using factor data, and obviously we can manage the potential asset failure. So again, these are some of the ways that you can better manage machinery, and you can use predictive modeling to help you to get there. And I encourage everyone who's interested to dive deeper into these examples. I highly encourage you to check out the blog post that I wrote on this topic about manufacturing and AI technologies. So moving forward to the next sort of topic that I would love to discuss is the concept of machine health, right? Machine failure is one side of the coin. Machine health is the other. The question is, how can we better operate machinery, and how do we better manage it so that failures do not occur? So it's one thing to predict failure, right? It's one thing to have a certain percentage of failure, the probability of failure rather. But it's another thing to ensure that, hey, this machine has a healthy status, this machine has a poor operating status, right? So coming up with these classifications for the machine health is the second really important use case to tackle if anyone is interested to use AI technology. Being able to understand the health of the machine is critical to the long-term health of the operation, right? What is the health of a machine, right? So I gave you one example: healthy, not healthy. But you can also think of it like a scale. So you can classify machinery based on a category, or you can attach a number and you can classify or do something called regression modeling, where we're aiming to attach a number to the health of the machine. Right? Again, is very similarly, or rather very closely tied to machine failure. So the health is tied to failure. On a score of 1 to 100, what is the health of that machinery, right? If we attach a number to that health, now we're able to understand, okay, well, one piece of machinery is at 50% health. One piece of machinery is at 90% health. And right away, if we use AI technology to classify or create a regression model and give a number to each machinery, now we're able to take proactive measures. We're able to proactively take action and proactively send in a crew that are able to inspect and perhaps improve the operation of the machine. So what can machine health tell us? Well, first of all, we know that a machine is operating under healthy conditions. What is the temperature of that machine? What are the sensors showing us? What is the vibration of that machine? All of this data is a very important data set to create in order for us to understand what is the health condition, right? If we're able to understand temperature, vibration, the operating schedule of machinery, and we can attach a numerical number for the health of that machine, now we can better manage the manufacturing state, right? And ultimately it comes down to what is the best way to manage the state of the manufacturing process. And if we give a number to each machine, now we're able to do proactive maintenance. We're able to come in before failure occurs, right? So this is why I say it's a two-sided coin. Failure and health are simply the same thing depending on your focus. You're either preventing failure or you're proactively ensuring the long, healthy lifespan of a machine, right? And this is the second use case that I wanted to mention. So for those who are joining us in the future, for those of our existing listeners, what are your thoughts on the machine failures and the machine health? Have you had a chance to deal with coming up with the maintenance schedules for your machinery? Have you had a chance to deal with machine that was taken off, that was sort of offline, and you had to manage the impacts of that downtime? Well, this is an important moment to reflect, right? If you have had a chance to deal with this, feel free to leave your comments in the section below. This is the second, I would say, most common use case that we see, that companies who are interested to use AI, they start going down this path. They start thinking about how can we prevent machine failure, and the next question is how can we ensure it is as operational as it can be, right? So again, lots of examples to go over. I've briefly mentioned two. So the third example that I want to mention, the third use case of how you go about using AI technology, is to basically do something called root cause analysis. Root cause analysis is a very important sort of process that must be done in order to understand what happened in the machine failure, right? So it's one thing to catch a moment in time, to take a snapshot of, hey, the machine was operating. The next snapshot says, hey, the machine is down. But actually, what happened, right? What was the series of events that led to the failure? Was there an overheating part of a machine? Was there a sort of improperly calibrated tool? What was the link that created the chain for the failure? This is called root cause analysis. Root cause analysis is critical when you're trying to understand what happened in the machine failure, right? So machine failure is the first use case I've mentioned so far. Root cause analysis is closely tied to machine failure. We're asking the question, how do we better understand what happened with failure? We're looking for a series of events. We're looking for cascading events, one event cascading into the next. We're looking for a series of steps that led to the machine sort of either breaking down or actually fully stopping its operation. But I also want to mention something important here, is that it's not just enough to know the failure. We also want to know what has led up to the failure. So perhaps we find that the temperature was the last straw to break the camel's back, if you were, that led to the failure. But what if the temperature was a byproduct of the vibration? What if the machine was vibrating too much, which caused the friction of the vibration to convert into kinetic and potential energy, which caused the temperature to rise? Well, without root cause analysis, if we just look at the failure, if we look at predictive models that aim to predict failure, what we will see is that the model will tell us that temperature was the root cause. But if we're looking at very specific modeling techniques where we're aiming to apply, again, similarly, either classification, regression, or prediction models to understand the root cause analysis, now we're able to say, hey, we have a failure that occurred because of vibration, which cascaded into temperature, which caused the machine to go down. So this is something to keep in mind, right? Root cause analysis is critical if we're trying to understand the failure that occurred that led up to the ultimate sort of downtime. Okay, well, it looks like we have more people joining us, and it looks like we have Maximilian from Canada as well. Hi, Max. It's great to have you with us as well. So I encourage you all, for everyone who is listening, for everyone who is watching, to leave your comments, leave your questions in the chat below or to the right side that is of my screen, that allows you to interact with me, to have a conversation. You know, this live stream is meant for me to share something with you, but also for me to interact with you. So this is an engaging, a two-way conversation, and I don't want you to think that what I'm telling you is the only way. There are so many ways to go about using AI technology to solve manufacturing problems, and I want this to be as interactive as possible. To come back to sort of the use cases. So far we've mentioned 3 use cases, right? The question is, what is the best way AI technology can help us to solve manufacturing problems? So far we discussed the first being predictive failure, right? We're aiming to understand when we need to do maintenance. The second is machine health. We're aiming to understand quantitatively what is the rating, what is the score of a particular machine. Again, this is also tied to maintenance. And the third is root cause analysis. This is where we're aiming to understand what events led up to the failure. So I encourage you, if you're interested to dive deeper into these use cases, is you visit the website that I shared with you previously. You can find the link in the comments below. It is a link to a blog post that I wrote that you can dive deeper into the topic. For now, I'm more than happy to move forward and sort of address the other use cases that I see, that my team sees, with how companies are using AI technology. Another good example is something called demand forecasting. Okay, we have a manufacturing facility, we have operation. That's awesome. Companies making millions of dollars, they are crushing the manufacturing process. But the question arises, how can they predict the changing market conditions, right? Let's look at COVID-19 as a great example of what happened in 2020. COVID-19 was the black swan of 2020. It was the event that nobody expected. It was the event that nobody had anticipated. And yet, COVID-19 was creating a new marketplace. It was creating a new data for manufacturing companies to understand and analyze. And what happened? Right? Manufacturing companies were caught off guard. Manufacturing companies, even those who used AI technologies, were overly reliant on historical data in their modeling process to predict or at least forecast demand. Right? Demand was coming from the market, from their competitors, from their customers, from what was being asked of the manufacturing companies. And that demand was all of a sudden shifting. It was changing. The driving force that was not expected was COVID-19, right? Now, we saw companies that go to zero in certain products. Other products went to 1,000%, right? One example, companies that were overly focused on creating local products that would be necessary for a local setting, went to zero. And so on the other side of the coin, you have products that were aiming to help humanity to better deal with COVID, went to 1,000+. An example of that is masks. All of the healthcare facilities needed machinery, needed hardware, needed products so that they could support the sick and sort of inattention consumers that were coming into hospitals and other healthcare facilities. So the healthcare industry saw a boost. And that boost, because of COVID-19, put a lot of pressure and demand to manufacture new products, or products that were considered not sort of the traditional products by the manufacturing companies. Manufacturing companies adjusted. They saw an increased demand, especially for healthcare. And sort of these dynamically changing conditions meant that companies needed to leverage technologies to be able to predict that new demand. So far I've mentioned, how companies were over-reliant on certain technologies, and AI was actually one of these technologies. So a good example, right? A lot of companies were using predictive modelings, and specifically they were using a technique called supervised learning. For those who are not familiar, supervised learning is a technique where you're aiming to give examples to a computer of what kind of data you're looking at, right? Perhaps you're giving examples of what is demand look like. On a Monday, demand looks like this. On a Tuesday, demand looks like this. Perhaps you're giving examples of what demand looks like by industry. Here's the demand for healthcare. Here's the demand for manufacturing. Here's the demand for government, etc. And these types of models, the supervised learning models that were being utilized by manufacturing companies, these AI systems that were already in place, because they were overly reliant on historical data, they actually struggled amid COVID-19, right? And now there are better technologies out there. So I just want to emphasize that, yes, some technologies did falter, did stumble during COVID-19, but we do have newer, more modern technologies that are proving to be more resilient. I'll give you 2 examples, and feel free to reach out to me and ask me additional questions, and I'm more than happy to give you specific examples of how you do that. So the first being, you have reinforcement learning as a very promising technology that's able to help companies to better deal with the dynamically changing marketplaces, with the dynamically changing sort of consumers and the ecosystem. Reinforcement learning is a technique that is used by AI community to understand through reward what an agent, or in this case, a virtual agent, should do. We're aiming to teach a system to be known through real-time data, right? And reinforcement learning has been proven to be more effective than supervised learning, especially when you had a massive shift of the demand, a massive shift of the market. The second example that I want to share with you is a technique called unsupervised learning, or self-supervised learning, depending on the circle you take. But the context of unsupervised learning is where we're aiming to teach computers to analyze data by itself. So we're not guiding the system through examples. We're saying, hey, computer, learn through the analysis of, for example, manufacturing data, and give us what we're looking for, either an understanding of the present or a prediction of the future. And only these types of models, the ones that are learning by themselves, they're more dynamically able to adjust to the real-time conditions that were sort of changing every single moment during COVID-19. So I gave you so far 2 examples of technologies that were very promising, that are better able to deal with dynamic data, and that is reinforcement learning and self-supervised or unsupervised learning. I want to reset this particular live stream. You are joining today because we are talking about artificial intelligence and how it helps manufacturing companies. I want to thank you for being here. I want to thank you for raising your hand, leaving comments, and making this live stream possible. Let's move forward. So far we've discussed 4 use cases of AI technology to solve manufacturing problems. One being predictive maintenance. Second is machine health. Third is root cause analysis. And fourth is demand forecasting. I also want to talk about another use case that I think is important to understand, which is production scheduling. So for those who are not familiar, the context of manufacturing products always involves the context of time, right? We have a temporal sense of every single part of the manufacturing process. We need to deliver by a certain day. That delivery must have a certain quantity. That quantity must meet a certain standard. And being able to schedule production in the most optimal way is the 5th use case that I wanted to share with you. And I think it's an important one because in a way we're looking at what is the capacity of our manufacturing, and we're aiming to predict what is the optimal schedule look like, right? When is it the best time to start the manufacturing process? When is it the best time to transition from one machine to the next? And when is the best time to go from finished product to a delivery? Now, yes, oftentimes companies are optimizing for speed. Speed is definitely one of the top priorities for manufacturing companies. Having said that, when you do have lots of machinery at play, when you have a manufacturing floor that's operational, sometimes 24/7, you want to use advanced technology to be able to manage the schedule. And AI technology that's able to understand when tasks begin, when manufacturing process is finished, that's the technology that's able to help you deal with scheduling. So how will this look like? The easiest example is a recommendation system. Okay, so you have lots of data. You have data of the capacity of the machine. You have data of the usage. You have data of the operational, sort of the patterns of the machine. You have data of the workers who are using the machine. And all this data, you need to make sense of it. So how do you do that, right? Well, think of it like this. We are creating a system that's making a recommendation for the schedule. We're creating a recommendation system. This is called a recommendation system, as the name implies. And this is actually one of the best ways to go about using AI technology. Recommendation systems are very common. They are found in all domains, not just manufacturing, and they surface insights, and in this case, recommendations for the manufacturing operators, for individuals who are in charge of the management, for individuals who are in charge of operation, for individuals who are in charge of quality control. They give you insight that you need to make your decisions, right? Recommendation systems are extremely powerful. They tell you what to do, when to do it. They can be tied with a notification system, so they're able to surface the information that you need at the time. So it's definitely a very important use case to solve. So far we've talked about 5 different use cases of AI technology, and I can keep going and on and on. There's just so many ways to apply AI technology to solve manufacturing problems. The real question is, what problem do you face? What is your biggest frustration? What is your biggest challenge, right? It always starts with sort of that personal realization. And once you have made that realization, now you can move forward. Now you can say, okay, we have the problem defined. Let's analyze all possible ways to solve it. Now, AI technology is just one tool in your tool belt that allows you to solve this type of problem. And so far, I've mentioned 5 different ways they can go about using AI to solve different problems. But I also want to talk about the technology of AI. So, I've so far been focusing on the manufacturing side and the use case side. But I want to touch base on the artificial intelligence perspective, because my specialty, the specialty of my company, we have done AI development for the last 8 years, and we see some technologies better than others. We see some best practices better than others, and I want to take the next 30 minutes or so to discuss the technology. For those who are joining us, this is an event where we're aiming to bridge the gap between the manufacturing and the AI industry. The next half an hour, I would like to focus more on artificial intelligence. I would love to share with you what are some of the best practices for using AI to solve general manufacturing problems. So the first major use case of AI technology is computer vision. For those who are not familiar, computer vision is a very unique technology that's able to help people answer questions related to images and video. On a manufacturing floor, that often involves us using sensors, that often involves the industry using cameras to understand what's happening on the production floor, what's happening on the manufacturing floor. Cameras today are by far the oil that we need to spark an AI system. It is the oil that we need to gather data. Right? So if we step back, if we're asking ourselves, how do we become AI-driven? Well, it always starts from the concept of becoming data-driven. And today, cameras, sensors, IoT devices on the manufacturing floor is by far the best strategy that any company can use to start to use AI technology. So let's say you do have IoT data. Let's say that data is collecting information about the manufacturing process. And let's say we're collecting visual data, right? This is the ground fork. This is the foundation I would like to establish. Envision a scenario where we have cameras on the manufacturing machinery itself. We have cameras on the manufacturing floor that are pointed and directed at people. So we're now able to visualize every single process of the manufacturing, both from the conveyor belt perspective and the manufacturing floor perspective. We can even attach cameras for the transportation angle. I mean, really, it doesn't matter what you are aiming to better understand. If you have a camera and you turn it on, you're now collecting the data you need to use computer vision technologies. So let's break this down. So what is AI from the perspective of computer vision? We're aiming to understand what's happening in real time using cameras. What is happening inside the image? What is happening inside the video? Is there a part passing through a conveyor belt? Well, now we have sensors that can tell us this information. And this is the easiest example of how we can classify the rate at which we manufacture. We don't need to count anymore. We can have sensors and computer vision driven models that visually identify objects, that do something called image classification, they do something called object detection, and they're able to tell us, for example, how many parts are moving on the conveyor belt, how many parts have started, how many parts are in process, how many parts are completed. Right? How useful is that information? If we're aiming to provide insight to the operators and we give them clear visibility to how many parts are defect, how many parts are manufactured, that's incredible and incredibly rich source of data for anyone to use. Okay, so now we have cameras on the production floor. We have cameras on the machines. What else can we do, right? We can use computer vision to not just understand what's happening, we can also use it to detect issues, right? So let's say we have a part being manufactured, is going through the production floor conveyor belt. And let's say traditionally we would rely on people to perform the quality control work. And let's say we would have a random sampling, an individual would walk up to the conveyor belt, pull an item off the shelf, and start to inspect the item being manufactured and look for tolerances, look for standards that have been set in place. Well, if there's any issue detected, the quality control person now has to make a change to the manufacturing floor. And this process takes time. This process is reliant on the person. And what happens if you want to operate at night? What happens if you don't have 2 quality control managers, if you just have 1? Well, this is actually the best use case of using a computer vision camera that's scanning the manufacturing process. If we're able to detect defects on the manufacturing floor, and we can do this 24/7, we're able to save massive amount of time and money in making sure that these defects do not make it into the shipment, that these defects are reworked and rehandled by the manufacturing process. So now imagine the system, an AI system, detecting defects, and imagine that system proactively taking action. Imagine a conveyor belt that is rerouting the products, and those products are now being reworked. We have less scraps, we have less issues with product, we have more reuse, and we're able to streamline the manufacturing process. Now, how valuable is that? If we're able to detect issues, detect more issues, detect issues in real time, detect issues 24/7, how valuable is that, right? It's invaluable. You need to quantify this data to understand the impact we're making, right? Now, I want to sort of lay the foundation here before I dive into the second use case of how individuals can use AI technology in the manufacturing process. I want to lay the foundation that I am pro people. I love people. I love interacting with people. I love talking to people. I love solving problems for people. But there are certain things that can be automated. There are certain things that should be automated. And there are certain things that people should not do, right? I have seen what accidents look like on the manufacturing facility. I know what kind of stress it creates for the individual, for the company, and for the family. It just doesn't make sense to ask people to do certain tasks on the manufacturing floor, especially tasks that are very risky. So this is the perfect use case for AI technology. Now, I'm not saying that AI technology will prevent sort of issues that occur on the manufacturing floor. I'm not saying it's the technology that will ensure people are healthier and safer. I'm just stating the fact that AI technology can do the work of individuals' tasks with specific tasks. So let's break this down. So there has been a lot of, on a high level, a lot of talk about AI technology replacing people's jobs. And I want to lay the foundation. It's not about replacing the jobs. It's about doing tasks better than people. That's it. It comes down to tasks. It's not about jobs. If we're aiming to answer the question, how do we create, for example, a safer manufacturing floor? We need to ask the question, how can AI technology help us to do certain tasks safer? We're not aiming to replace jobs. We're aiming to replace tasks. And when you think of it from that perspective, you realize that, well, actually, there's certain things that people do that are either boring, tedious, or pure unsafe. This is the best way that you can go about using AI technology. So when I speak to companies, and when some companies are hesitant about going and investing resources into AI technologies, when they're considering investing billions, millions, or thousands of dollars into the technology, they need to realize that it comes down to what makes more sense for a business. What is the vision of the business, right? Start with the vision, start with the end in mind. Do you want to provide as much value possible for your customers? Do you want to create a safe manufacturing floor? And what is the cost associated with hiring a human agent? And what is the cost associated with hiring a virtual agent? And when you break it down from that perspective, you quickly realize that, well, actually, in some cases, it's cheaper to develop an AI system. It's cheaper to leverage robotics and artificial intelligence than it is to hire a team of 10 humans to do the same. Some tasks should be done by people. Other tasks should not be done by people. And this is my my particular foundation that I want to establish here before I move on to the second use case of the AI technology. Yes, robotics is out there. Yes, AI is out there. But it comes down to what is the vision that you want to achieve. And if you attach that vision to what is the return on investment or what is the cost of that vision, then you realize that actually AI technology is better, or not having a person do the task is better. And so this is a specific example that I wanted to share with you. Okay, so the second use case of AI technology, and I want to reset the room for everyone joining. This live stream is meant to educate, inspire, and share best practices for how entrepreneurs, executives, and decision makers can leverage AI technology to solve industry problems. Today, we're discussing manufacturing and AI. And the second AI technology that is very promising, that is very powerful, is natural language processing. NLP for short. This is an amazing technology that allows anyone to better understand conversational data. So let's establish the foundation. If we do have a manufacturing floor and you do have people, agents on that manufacturing floor, and they do speak and they do communicate with each other, this is the foundation that you need. This is the data you need to apply NLP. Now, NLP is not to be confused with neuro-linguistic programming. This is an acronym that's meant to describe natural language processing. So for those who are Googling, you may run into this sort of dichotomy of two different industries talking about the same term. Our context is AI, and we're talking about how computers can help people to understand language. NLP is that abbreviation. Natural language processing allows anyone to understand speech conversation and written conversation. So these are two very important areas to consider. So some companies are creating massive amount of data as they're interacting with their customers, right? It's a manufacturing facility, it's a manufacturing company, they're manufacturing products, and they're interacting either by phone, by email, or other means with their customers. Well, this is the foundation that you need for NLP. Okay, now let's consider a different use case here. Let's say we are thinking about the context of how do we use audio data, right? So we're not looking at textual or text data that we can understand and read with our eyes. We're looking at audio data. And audio data can be described using natural language processing. We can apply specific techniques of AI. One example is speech recognition. Second is speaker identification, or third being sentiment classification or sentence classification. So these are just three examples of how you go about using NLP, but the context is we're applying AI technology to solve NLP problems. So if you do have data, if you're collecting conversational data, if you're collecting audio data, you want to answer the question, what insight can you drive from that data? What is that piece of information that you can surface that allows you to make better decisions? And the easiest way to think of it is from the perspective of customer, right? If you're analyzing customer conversation, you're surfacing which customers need more attention. You're surfacing which companies need higher priority of service. You're surfacing which customers are more dissatisfied with your product, which customers are influencers and are sharing your product online. So all of these are just a few examples of how companies can use AI technology to better understand their customers. The second example I want to share with you is collecting audio data from the machinery, right? So remember before I talked about the context of how do you predict failure of a machine? How do you classify machines based on their health? Well, another way you can better understand what's happening is if you use IoT data, if you record data using sensors to collect information about the sound or the vibration of the machinery. This is critical data, right? This data is already there. You just need to tap into this data source. The audio data that's coming from machines is critical to the understanding of the machine state. You need to know what kind of vibration, what kind of sound the machine is making. And this is where you can start to use AI technology to differentiate very subtle variations of sound. You can start to differentiate very subtle changes in how the machine operates. And the sound analysis that you do is closely tied to speech recognition, which is a subset of natural language processing. So I just wanted to bring that example because, yes, you can analyze human conversational data, audio data, textual data, but you can also analyze machinery data, and that data can come from vibration and sound. So this is another example that I want to highlight for everyone who is listening and watching this particular live stream. I want to reset this event for everyone who's joining us. Today we are discussing how to bridge the gap between manufacturing and AI. I am your host, Slava Kurilak. I am the founder CEO at Purdue, where we help 1 million plus in revenue companies to scale to the next level by developing AI technologies. I encourage everyone to leave a comment below or to my right, depending on the screen you're using, and I am more than happy to address your comments during this live stream. Your comments now are showing up as an overlay, so if you're joining this live stream, you can actually see them appear on your screen, which makes it a little bit more visual. Great. So moving forward, so far we've discussed 5 different use cases of how manufacturing can solve problems using AI. I've given you 2 specific AI technologies that allow anyone to solve manufacturing problems. And I want to start wrapping up this live stream. I would like to have a little buffer for you to think about. I would like to conclude with a few, I would say, trends and a few predictions for the manufacturing space. So the first prediction I'm making is that I believe that computing technologies will continue to drive massive value in manufacturing. Again, computer vision is a technology that deals with images and video. And today's modern companies are using today's manufacturing companies are using modern technologies like computer vision to solve visual data problems. There's a lot of data out there, and being able to solve these problems is very critical. And being able to understand what's happening on the manufacturing floor, on the production floor, on the distribution site is critical. The second prediction I want to make is I think that we will see the emergence of new technology focusing in on generative models. And these models will allow us to create better simulations of the manufacturing process. So, yes, a lot of companies are using machinery, using people to do the manufacture of products. And yes, they are very critical in the foundation of data sets. Having said that, creating simulations for different manufacturing processes is critical to the success of a company, right? So the closest analogy I can give you is the analogy during COVID-19, ways that people dealt with COVID-19. We were simulating what COVID-19 does once it's exposed to a certain population, right? We had groups, we had research, we had institutions that were aiming to solve the question of how many new cases do we expect? How many cases are we expecting to be admitted into hospitals? And what will happen next for COVID-19, right? These simulations that were done often involved AI technology and often involved using statistics, and more recently, they involved using generative models. Now, for those who are not familiar, generative models is an amazing technology that helps individuals to computationally create something that did not exist before. right? So this is different from supervised learning. Generative models are creating something, they're generating something that is new, something that is novel, something that often seems creative. And generative models are a really good way to go about simulation. There are other technologies as well, but I just want to highlight generative models because I think they are very promising for anyone to consider if they are to think about what happens next. You know, what is the next best way for us to predict demand? What is the next way for us to better manage our supply? Predictive models allow us to do that. Generative models allow us to do that. And the second prediction I want to make is that generative models, I think, will be one of the better ways, combined with predictive models, to create simulations of the manufacturing process. And simulations allow us to better understand the future, which allows us to better make financial decisions in the present. And the third prediction I want to make for the industry is that we're going to see more and more companies ready for AI technologies. You know, today, a lot of companies are accelerated. They are bootstrapped into becoming data-driven. You know, the catalyst of 2020 was COVID-19. And so 2021, I see as the year where companies start to embrace AI technologies, leveraging the data that they started to collect as the result of COVID-19. Right? COVID-19 forced a lot of companies to adjust. COVID-19 forced a lot of companies to become digital, to adapt digital transformation. And so AI technology that's able to leverage data will be the best possible technology to deal with the dynamic changing data sets of tomorrow. And I want to just highlight for those who are listening that if you want to understand the technology that I think is better suited for the dynamically changing data sets, you know, look into unsupervised learning, self-supervised learning, and reinforcement learning. And feel free to rewind this live event, go back to where I discussed this at an earlier time. And I would like to start wrapping this up. You know, I want to thank everyone who has joined us. I want to thank everyone who has posted a comment, everyone who has posted where they're from. You know, it's been great to connect with you and to share insights about AI technologies in manufacturing. I also want to encourage everyone who is watching, everyone who is listening, to subscribe to Produvia by going to produvia.com. That's PRODUVIA.com/subscribe. What I'll do now is I'll actually type the link in the comment section, and that's going to make it easier for everyone to actually click and subscribe to our upcoming events, our upcoming live events. This particular event is hosted on multiple social media channels. So if you found this through one channel, feel free to explore other social networks. We are live streaming right now to Facebook, LinkedIn, YouTube, OK, VK, Periscope, and others. So I highly encourage you to look into other broadcasts if you're interested to consume this content at your own preference, at your own platform. I want to conclude with a call to action. Are you using AI technology today? I encourage you to start thinking past collecting data. I encourage you to reach out and schedule a one-on-one discovery call with me where we can chat about how you can solve manufacturing problems using AI technologies. You can do this by going to produvia.com/start. And again, what I'll do is I'll share the link in the comments below, and I encourage everyone to click through and schedule a phone call with me. So what you can expect on this phone call is for me to ask you questions like, what do you want to see in this world? What impact do you want to make? Please describe to me your vision for manufacturing. And these are very important questions to address because it allows me and my team to better offer our machine learning development service to you. And for those who are not familiar, Produvia is a artificial intelligence agency which helps companies to scale to the next level. We do this by developing custom AI solutions so our customers can leverage these exponential technologies. So if you're interested to learn more about us, feel free to check out produvia.com. And again, I will share a link in the comments below, so feel free to click it and then check it out. So far, I have discussed with you the 5 different use cases of AI in manufacturing. I gave you 2 AI technologies that I think are very powerful, and I gave you 3 AI predictions for manufacturing. And I encourage you to schedule that phone call so you and I can have a one-on-one conversation about what it means to apply AI to solve manufacturing problems. I want to thank you for joining me. I want to thank you for leaving comments. Thank you, everyone, for being here. It's great for you to join us on a Saturday at 4 p.m. Pacific Standard Time. Tomorrow, I want to conclude that I will have an upcoming live stream, same time as it is today. So anyone who's interested to learn more about how they can use AI technology to solve industry problems, I urge you to join tomorrow. That said, thank you for your time, and I will see you tomorrow.